Welcome to our lesson on acids and bases. Today we'll explore these fascinating chemical compounds that are essential in our everyday life. We will learn about their properties, where can we find them, and how they react with other substances. This presentation is designed to make this concept visual and easy to understand. Acids and bases are all around us in our daily lives. Acids are found in many food we eat. The citrus fruits contain citric acid, yogurt contains lactic acid, vinegar contains acetic acid, and carbonated drinks contains phosphoric and carbonic acids. These give food their sour taste. Bases are found in many household products. You can find them in soap, cleaning products. They often contain bases, which gives them their slippery feel. Baking soda, sodium bicarbonate, is a common base used in cooking antacids, which neutralizes stomach acid if you have heartburn. Acids are also with bases essential in our bodies too. Our stomach produces hydrochloric acid to help digest food, while our blood contains buffers to maintain a slightly basic pH. Acids have distinctive properties that help identify them. Number one, they have a sour taste. They have a characteristic sour taste. Think of lemons or vinegar. However, you would never taste laboratory chemicals. Number two, they turn the litmus paper into red. Acids turn blue litmus paper red, which is a simple way to identify them. Number three, they conduct electricity. When dissolved in water, acids form ions that conduct electricity. Number four, they are corrosive. So many acids, especially strong ones, can be corrosive to metals and organic materials. Number five, they react with metals. Many acids react with many metals to produce a hydrogen gas and salt. The general equation is acid plus metal give us salt and hydrogen gas. Number six, they react with carbonates. Acids reacts with some compounds called carbonates to produce carbon dioxide, water, and salt. The general equation is acid plus carbonate give us salt plus water and carbon dioxide. The interactive litmus test shows us how blue litmus paper turns into red in the presence of acid. The bases have their own set of properties. They have bitter taste, though again we should never taste laboratory chemicals. Litmus paper test. Bases with red litmus paper. Bases turn the red litmus paper into blue. So let's try to see the difference. This is an acid, and I will put it on the blue litmus paper. So if I test it, it will change into a red color. So again, let's do this. This is an acid, and I put it on the blue litmus paper. It will change into color into red, while the opposite happens if I have a base. I put the base on the red litmus paper, is gonna change into red. So the acids change the blue litmus paper into red, while the bases change the red litmus paper into blue. So like acids, bases form ions also. That's why it conduct electricity. Number four, they feel slippery or soapy when touched. This is why soap which contains bases feels slippery. The number five, they can be corrosive also like acids. Number six, they neutralize acids. Neutralization means that the bases react with acids to form water and salt, so they neutralize each other. The acid neutralizes the base and the base neutralizes the acid in what's known as a neutralization reaction. Acids are found in many common foods in our bodies. Citric acid is found in citrus fruits like lemons, limes, orange, and grapefruits. It gives them their sour taste. Acetic acid is the main component of vinegar used in cooking, pickling, and a household cleaner. Lactic acid is found in yogurt and other fermented dairy products. It's also produced in our muscles during intense exercise, causing them to having this burning sensation. Hydrochloric acid is produced by our stomach to help digest food and kill harmful bacteria. It's strong, which means that it has a pH around 1.5 to 3.5. Safety note, laboratory acids can be dangerous. Always wear protective equipment like goggles and gloves when handling them, and never test them, and always add acid to water, not water to acid when diluting the acid. So you have to have many safety precautions when you are working with laboratory acids. Bases, on the other side, are also found in many uses. I can find them in sodium bicarbonate. This is a baking soda used in cooking to help the dough rise by carbon dioxide gas. When heated or mixed with acidic ingredients, it produces the carbon dioxide gas bubbles. Number two, magnesium hydroxide, which is found in milk of magnesia and other antacids. It neutralizes excess stomach acid to relieve the heartburn and indigestion. Sodium hydroxide or caustic soda is used in soap making, cleaners, and many industrial processes. It's very strong base. Ammonia found in many household cleaning products. It's good at cutting through grease and grime. Safety note: strong bases can be just as dangerous as strong acids. They can cause chemical burns and should be handled with care. Always wear protective equipment and follow the safety guidelines. When acids react with metals, they produce salt and hydrogen gas. So any acid plus the metal, like magnesium for example, forms salt and hydrogen gas. This is a type of single displacement reaction. The general equation is that acid reacts with metal to form salt and hydrogen gas. A common example is the reaction between hydrochloric acid and magnesium, MgS, reacts with 2HCl, which is aqueous for sure, to form magnesium chloride. This is aqueous because it is soluble, and hydrogen gas. The magnesium metal displaces the hydrogen, so it takes its place. And instead of being hydrogen with the chlorine, the magnesium comes instead of the hydrogen and forms MgCl₂. Hydrogen gas is released, which can be observed as bubbles. Not all metals react with acids at the same rate. More reactive metals like potassium, sodium, and magnesium react vigorously, while less reactive metals like copper and silver react slowly or not at all. This reaction is used in various applications, including metal cleaning and hydrogen gas production. When acids react with another type of compounds called carbonates, they produce this time salt and water and carbon dioxide. This is why we see fizzing or effervescence when acid is added to carbonate. The general equation is that the acid plus the carbonate forms salt and water and carbon dioxide. A common example is the reaction between acetic acid in vinegar and calcium carbonate in chalk or limestone. In this reaction, the acid reacts with the carbonate. A salt, which is calcium acetate, is formed. Water is produced and carbon dioxide gas is released, causing the fizzing. This reaction has many practical applications. It can be used in antacids containing carbonates, neutralize stomach and release carbon dioxide. Baking powder contains acid and carbonate that reacts when wet to make baked goods rise. A reaction is responsible for the erosion of limestone and may be also destroy some marble buildings by the acid rain. Neutralization reaction is a chemical reaction in which acid and base react to form salt and water. This reaction is called neutralization because the acid and base neutralize each other properties. The general equation is acid plus base give us salt plus water. A common example is the reaction between hydrochloric acid and sodium hydroxide to form sodium chloride and water. In this reaction, the hydrogen ion from the acid combines with the hydroxide ion from the base to form water. The remaining ions from salt, in this case sodium chloride or table salt. Neutralization reactions have many practical applications. Antacids neutralize excess stomach acids to relieve the heartburn. Farmers add lime like calcium oxide to neutralize the acidic soil. Neutralization is used in wastewater treatment to adjust the pH before discharge. Many industrial processes require precise pH control through the neutralization. Acids and bases are essential in many real-world applications. Antacids, these medicines contain bases like magnesium hydroxide or calcium carbonate that neutralize the excess stomach acid to relieve the heartburn and indigestion. The neutralization reaction produces water, a salt, and sometimes carbon dioxide. Baking soda, sodium bicarbonate, reacts with acidic ingredients like butter, milk, yogurt, or vinegar to produce carbon dioxide gas. The gas forms bubbles in the dough and making it rise and creating a light, fluffy texture in baked goods. Agriculture, farmer test soil. The farmers test soil pH and add lime, calcium oxide to neutralize acid soil or add sulfur to make the alkaline soil more acidic. This helps optimize the conditions for plant growth. Different plants prefer pH levels. Industry acids and bases are used in countless industrial processes, including paper manufacturing, textile production, metal processing and cleaning, food processing, pharmaceutical production, water treatment. Understanding acid and base chemistry is crucial for many processes from cooking to medicine to environmental science. So let's review what we have learned about acids and bases. Acids have a sour taste, like lemon or vinegar. Turn blue litmus paper red. React with metals to produce hydrogen gas. React with carbonates to produce carbon dioxide gas. Examples include citric acid, acetic acid, hydrochloric acid, and bases have a bitter taste. Turn red litmus paper blue. Feel slippery or soapy. Neutralize acids to form salt and water. Examples include sodium bicarbonate, sodium hydroxide, magnesium hydroxide. The neutralization reaction between acids and bases is one of the most important reactions in chemistry. Acid plus base give us salt plus water. Understanding acids and bases help us explain many everyday phenomena and is essential for fields ranging from cooking to medicine to environmental science. Thank you. If you have any questions, please put them inside the comment section and I'll be happy to help. See you next video.